I'd like to talk about measuring electricity, but of course to do that, I'm going to have to talk about measuring something else. So let's talk about rivers. If I was to measure this river, I could measure how long it is, how wide it is. Maybe I might want to measure how much water is in it, or how fast the water is moving. Measuring electricity is very similar. So, of course, if I am standing at a river, and for the sake of explaining this, let's just draw a river. It's going to have a waterfall at the end, which we'll understand why later. So here's our river. Of course, we could have some water in it, and that water is moving in this direction. Okay, so you and I are, or perhaps just one of us, is standing at the edge of the river here, and we're looking at how much water is flowing by. And we'd love to measure that, and there's all kinds of things we could do. We could measure it in the number of drops moving by. There is maybe 1 trillion droplets of water moving by every second, and I could say there is 1 trillion droplets moving by per second. But of course, 1 trillion is a big number to work with, and we'd rather work with much smaller numbers than that. Measuring electricity is very similar. Of course, we're not talking about droplets of water, we're talking about the movement of electrons, right? Because electricity is moving electrons. So, we're not going to talk about individual electrons because there's far too many moving at once. We're going to talk about coulombs. And 1 coulomb, and the symbol for that is just a capital C. 1 coulomb is 6.25 times 10 to the 18 electrons, which really just means 6 billion electrons. That's 2 billion. 6 billion electrons is 1 coulomb. And so, if you think about maybe 6 billion droplets of water might fill, I don't know, a swimming pool perhaps. So if you're looking at this river and you're saying, okay, I don't know how many droplets are going by, but it looks like maybe 1 swimming pool's worth is moving by every second. So here's a swimming pool's worth of water, and then of course 1 second later that swimming pool is further downstream. So in 1 simple second we have seen 1 swimming pool's worth move by, which is a lot easier than saying 6 billion droplets have moved by in 1 second. We can just say 1 swimming pool per second. It just so happens when we're talking about electricity that 1 coulomb of electrons moving by in 1 second, so 1 coulomb in 1 second is equal to 1 ampere, or we'll just say 1 amp. So 1 amp, that's a capital A, is equal to 6 billion electrons, or 1 coulomb of electrons moving by every second. So 1 coulomb in 1 second. So measuring current is measuring. If you measure the current of water, you're talking about how much water is moving by every second. If you're measuring the current in electricity, you're talking about how many electrons are moving by every second. So current refers to the rate of movement of electrical charge. So it's not necessarily how much electrical charge there is, it's the rate at which it's moving. So how many electrons would be the number of coulombs, and how quickly they're moving, or how many pass by in each second, that's amps. That's current. So current is measured in amps. Current is amps. So just to summarize, current is measured in amps, it's capital A, and that's just the rate of flow. How many electrons are moving by you, how many coulombs of electrons are moving by a certain point every second. So that's the rate of flow. Now why do we have a waterfall here? Well, let's say this river is fairly, it's up high, it's flowing down. As it flows downstream, of course it's got to be angled somewhat downwards because it's gravity that's causing this water to move. But at some point we might have a really steep drop off, which we might call a waterfall. And then at the bottom of the waterfall, water will continue moving downstream. And just kind of a continuation of the river. So here we have a river. Oops. Let's try that again. Okay, there, we got it fixed. So we have a river, we have a waterfall, and then we have the river continuing. Now, we can measure the rate of flow at any given point. We can measure it here, we can measure it here, we can measure it here. But I'm not really interested in that right now. What I'm actually interested in is potential energy. So, remember, once again, you or I are standing by the river and we're watching things go by, and for some reason we are tempted to jump into the river. So here we are. Now, if I jump into the river here, all it's going to do is it's going to kind of move me along. And if I jump into the river down here, it's probably just going to move me along as well. Now, which part of the river is it most dangerous to jump into? Well, that's probably pretty obvious. It's most dangerous to jump in here, not because the water is moving any faster, but because it has the potential to throw me down a waterfall. And that potential is what gives it the danger. And it's the same thing with potential energy. So for instance, up here we have potential energy. We have a lot of potential energy. And down here we have less potential energy. Right? Because up here we have the potential to go over the waterfall and cause some damage. And at the bottom we do not have that potential. If we were in some way able to measure the difference between a lot of potential and less potential, we might call that the potential difference. And in electricity we do something exactly like that. In electricity, potential difference might also be called voltage. We call it voltage because the unit we measure it in is volts, which of course is done with a capital V. So voltage is potential difference. Now this might be kind of a complicated concept, and I admit that even I find this confusing sometimes, but perhaps this will help you understand. When we're talking about current, we're talking about, let's say, perhaps 1 coulomb of electrons. That's 6 billion electrons, and we can measure how fast it moves. And that's current. So how many coulombs is moving by us every second? But every coulomb of electrons is also carrying with it a certain amount of energy, and that energy, that potential energy, can be less or more. The amount of potential energy that every coulomb carries is precisely the voltage. So if we want to get technical down here for just a minute, energy is measured in joules, and if you have 1 joule for every coulomb, that would mean that you have 1 volt of potential difference. So if you're carrying a little bit more energy, say 2 joules per coulomb, then you would have 2 volts. That's kind of the technical way of figuring out exactly what a volt is. And so, to summarize, current is the rate of flow, how quickly the electrons are flowing by, and voltage is the potential difference, or the amount of energy that all of those electrons are carrying with them.